Okay, here we go, 14. The graph of f is shown. That's really all they say. Just that's out. They ask you to figure out these three. Number one says the domain of the derivative of f. The domain of the derivative of f. That means the domain of f prime. The domain of f prime is the open interval a to b. And here's a place where people make a lot of mistakes. Okay, you cannot skim when you're reading an AP test question. You can't just read it quick and do things like this. Oh, let's see, domain a to b. You just can't jump around. You have to read what's written. Here's a good example of that. This little notation, parenthesis, a comma b parenthesis. On the AP test, that will have two different meanings. And the only way you'll know which meaning you should use is the context of the reading. So raise your hand if you know what the two meanings of that symbol is. Like when you see on the AP test this, that has two different meanings. You have to know both of them. I've been joking with students. In other classes, when the teacher says, here are two methods, I know what you all do. You say, just show me the best one. Ignore the other. Okay? The AP test writers will not let you do that. They will test you on both things. So what are the two meanings of this? Everybody knows? Let's go there.
So there's an actual xy point, or it's the range on the x-axis.
How many knew that? 0.2 per there. Perfect. So this could be x equals a, y equals b. Or it could be, as you said, x-axis from a to b. Questions? Awesome. This is open interval. That means we don't actually include a or b. We just get infinitesimally close. Closed interval would mean we start precisely at a, end precisely at b. The closed interval is indicated with brackets. So this would be a closed interval. In the reading here, we know it's an interval because they say the interval. Okay, domain of the derivative of f. Domain means the following. We have a function f prime. We have all these x coordinates, we have all these y coordinates. For the function f prime, hands up, where do the y coordinates come from? Show me your hand. Like, where do all these y coordinates come from? Everybody who knows? Let's go, Julie. Tangent slopes of f. Perfect. How many knew that? 0.2 for Julia. And don't take points if you're not raising your hand. It's the hand raising that gives me clues as to how well you're understanding, how much I should explain. Because I don't want to keep going on and on if you're like, oh, you already understand that. Anyway, f prime. So I look over here. I'm like, oh, I can find the tangent slope here. I can find the tangent slope here, 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 blah, blah, blah. So I'm finding all these different tangent slopes. They're becoming all these different y coordinates. There's a problem that I am noticing that I didn't really mention. Who sees the problem? So I'm trying to find all these different values, which are all these different tangent slopes. What's the problem I'm going to run into? People always ask about doing reviews for tests. This is way better than a review. Like just interactive quizzing, the best way to just keep saying, oh, I didn't know that. Better make a flashcard. Better ask about that. So let's go ahead.
Is it that they're all going to be the same, at least from A to C and then from C to D?
That's for sure. Like this is linear, so every one of these slope values will be the same number. I don't know what that number is, but maybe it's a slope of 2 or something. So I'm going to have a slope of 2 at a whole bunch of different points. Then on this back side, seems pretty symmetric. So it's going to be a whole bunch of slopes that are like -2. Raise your hand if you were thinking what Hannah said. Point for that too for Hannah. There's another thing I'm noticing that's very significant. So tell me. There's a corner right here on F. Now again, don't use the word it, but also don't just say there's a corner. Be very specific. F has a corner. How many knew that? 0.2 for Tommy. What's the problem? Hands, come on. What's the problem? What's the problem? Colby, sorry. So say it just a tiny bit more specific, and make sure you use the word f, f prime, or f double prime.
F prime doesn't have a point at C.
So at x equals c, f prime has no y coordinate. He said that really well. Hold on a second, let somebody else to say something. Describe what's happening here using this, the term f instead of f prime. Somebody. How would you say what Colby just said, but using f instead of f prime? How would you describe it? He said on the graph of f prime, he said f prime doesn't have a point at x equals c. True. No y coordinate on f prime at x equals c. How do you say that same thing using the word f instead? Let's go, Andrew.
F is not, wow, sorry. F is not differentiable.
That works perfectly. F is not differentiable at c. The other one I was thinking of is I can't find the tangent slope of f at c. Okay, are you hearing how specific you need to think? If you think generally, you'll make mistakes. Think specific. F, f prime, etc. How many would have said that and your hand was raised? Point. Okay, 2 for Andrew. So if I'm trying to create f prime, I can find every y value of f prime except when x equals c. Then I can't find one. Therefore, c is not in the domain of f prime. So because c is between a and b, c is not in the domain of f prime. Therefore, the domain of the derivative is not the open interval a to b. This is a false statement. Okay, questions, please.
I don't understand what the open interval is.
No worries. So when you have a graph, the intervals of the graph are simply different sections of the graph.
Yeah.
So like they're saying, start at some x, go to some other x. So open interval a to b is saying, start at an x coordinate that is slightly to the right of a, infinitesimally to the right of a. Continue including every x coordinate until you get almost to b. Stop when you are just infinitesimally close to b.
Right.
That wasn't your question though, then.
I don't know, the wording just doesn't make sense. How do you have a domain of open interval?
So try this, see if it helps. Keep talking. Points for Nathan here every time I say your name. Okay, when I say domain of a function, all I'm saying is the function is a big long list of xy values.
Yeah.
Every x that has a y, that x is in the domain. That x is in the domain of the function. So the domain of f prime begins with an x coordinate that is slightly more than a, like just a little bit positive of a, because at that x, I can find the slope of f, which means I can find the y coordinate of f prime. Then I go to the next x coordinate, which is just a little bit more than that, and I can find the slope of f, so I can find the y coordinate of f prime. But when I get to x equals c, I can't find the y coordinate.
Yeah.
So c is not in the domain of f prime. It's not in the list of x values that have y values. Open interval is just saying every x
From A to B.
from a to b. Every x from a to b. C is one of those x's from a to b, but c is not in the domain.
Right.
Does that help?
Yeah, that makes a lot more sense.
Much better, Nathan. Good work. Okay, compliments to Nathan. There's 3 total. That's what you have to do in this class. When it doesn't make sense, you just have to keep pushing. You just keep talking. Just keep saying, I don't see it, I don't see it, I don't see it. And if I can't say it in a way that helps, we'll find somebody who can. So, other questions, sir? Please, Julie. The y value. The x value simply tells us the location. So if I come to an x coordinate that is slightly positive of a, I'd be looking kind of here, and I'm looking at that tangent slope at that spot, and I'm just making up the number 2. But the tangent slope at that spot is 2, So the y coordinate of f prime is the same as the tangent slope of f at that spot. Go
The
ahead.
reason why the domain is not, because they're all the same.
Perfect. The fact that they're all the same is actually irrelevant. It is an accurate observation, but not important. What's important is at x equals c, I do not have a y coordinate on f prime. Therefore, x equals c is not in the domain of f prime. Good? 2 points. Look over here. This is why I'm so tired at the end of the day. Because mentally, it's not, look, it's not hard to explain something one way and then just say, hey, it's up to you to get it or not. Good luck. That's easy. But to me, what's hard is, like, I need you to talk so I can try and think how you are thinking. That's really mentally taxing. Try to get my head to be just like yours and say, I think I know what you're saying. Is this it? This is a classic AP test tactic. They're trying to see if you understand what differentiable means. But they don't say the word differentiable anywhere. That's an AP test question. And they just create a creative way to gauge whether you know what differentiable means. And unfortunately, they throw in a couple of other concepts along the way. Like you have to know what domain means. Okay? You have to know what derivative means. That's a very classic AP tactic. F is continuous on the open interval a to b. Raise your hand if you know whether that's true or false. What hand? Is F continuous on the open interval a to b? And you have to have a reason why. If you don't know why, you are wasting your time. So, Brendan?
Because it doesn't stop, like you can keep going the whole way.
It's a really good answer. Really, that's a really good why. That I can draw F without lifting my pen. So I can draw F without lifting my pen. F is therefore continuous. That would make this a true statement. How many knew it before Brendan said it? Point to Brendan. Okay. Questions? Everybody understood that you reset your tally marks, right? Any carryover you can continue adding to it. So, like if you got 129 tallies, you pick up 12 tickets. So now you start with 9 and just go from there. Questions about that? Awesome. The derivative of f, that means f prime, is positive on the open interval a to c. So is f prime positive from a to c? Hands up, who knows? True or false, and why? True or false, and what is the reason? Let's go, Lily.
It's true because from A to C it's just increasing, so the derivative will be positive.
So you're perfectly correct. I want you to say it one more time without this.
Oh.
You're good.
F is increasing, so then the derivative of F will be positive.
It's perfect. It's perfect. How many knew it? Point, shoot for Lily. Okay. Any follow-up questions here, please?
So I just have a question, like, how do you go from taking the tangent slope of f and getting like, and making the graph out of f to f prime? Like, just off each tangent slope, how does it like show us?
No, really good question, Brendan. Let me attempt to answer your question. If I don't, keep asking, okay? There's no numbers on this scale, so we have no real way of computing the slopes, but it is clear that each of these slopes is the same. So are you okay with this assumption for now? Okay. The way I would plot f prime would be this. So let's see. I have a graph like so. This is f prime. I'm going from x equal a to x equal b. There's a point C at some spot. And what it is every y coordinate of f prime. We've already figured out that every one of these y coordinates is a tangent slope of f. So you're okay with the number?
Yeah.
Awesome. So this just becomes a y coordinate on the f prime graph. So here's 2, here's -2, and I'd say, let's see, so I have a point right here, and another one, and another one, and another one. So basically when you put an infinite number of points there, it looks like a horizontal line whose value is always 2. When I get to exactly x equals c, there is no point So draw the ghost point. Like that. Then right after x equals c, the value of the slope of f becomes -2. So I have a whole bunch of points down here that when I put them all together, I get another horizontal line like that.
Okay.
Is that your question?
Yeah.
2 points.
I'm not sure like how important this is. It's like a question about like corners and how they affect the derivative. Is it always going to be a jump discontinuity with the corner? And we'll always have 2 open circles instead of having like 1 closed circle and 1 open circle?
2 comments about that, 2 points for math. Just for everyone. Everyone look. If this helps you gain understanding, extremely valuable. It's a really good question. I've never seen AP questions where they just don't ask for graphing much. They ask for like matching graphs, that sort of thing. But really uncommon to say create the graph. So it's not really something I would worry too much about, although like I said, it helps understanding, really helpful. With regard to your question, I want everyone in the room to answer it. Okay, a corner means, so if f has a corner, that means the slope of f changes abruptly. The slope of f is undefined at the corner, but on either side of the corner, the slope of f is going to be different. In a normal curve, as you go from infinitesimal point to infinitesimal point, the slope is changing by an infinitesimal amount. But on a corner, the slope will suddenly change by some finite amount. So answer Matt's question. At the corner, he said, will the y coordinate of f prime always be missing? Depends if you know that. If f has a corner, will the y coordinate of f prime always be missing at the location of the corner? Mallory?
Yes.
Let me agree with Mallory. Point 2. Yeah, missing because you can't find the point there. His follow-up question was, will f prime always have a jump at the spot where f has a corner? How many can answer that? Yes or no, and why? Let's go Ellis.
Yes, it will,
And why?
because the slope of f changes immediately.
Perfect. The y coordinates that we see on f prime are the slopes of f. And if on either side of the corner the slope of f is different, then yes, I'm going to have a jump at the corner, as I have to indicate that the slope changed by some amount. How many knew it? 0.2 for all. Okay. Answer your question.
Yeah.
Please, Hannah.
Can we do one where we, okay, sorry, I don't know.
You're fine.
You know how we graphed the derivative of f without knowing the numbers? Can we do one where we do know the numbers? Because I'm a little bit confused on how.
The only difference, like you're wondering how we find the numbers?
Yeah, well, like, especially on a curve, like.
Oh, I think I know your question. If I'm wrong, just correct me. We did a little bit of work in the homework where we used the calculator to find the derivative's value at certain points. But for this test, you won't have to do any of that. You are not expected yet to be able to look at a curve and identify the slope, other than knowing that the slope is either positive or negative, and kind of knowing if it's a little bit positive or really positive. That's all you need.
Okay.
Does that answer your question? Okay. Anybody else here? Okay, next one. Let's pause this.